Since the arrival of the Juno probe on Jupiter, scientists have changed their perspective of the universe drastically. The $1 billion worth probe has captured some of the most amazing photographs of the gas giant, revealing what has remained hidden for so long. So what exactly has the Juno spacecraft revealed? Let's find out. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about some unexpected discoveries made by NASA's Juno spacecraft on Jupiter. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. NASA's Juno probe reached Jupiter in July 2016, and scientists' view of the solar system has not been the same since. The $1 billion mission has taken stunning pictures of the gas giant several hundred million miles from Earth. More importantly though, the tennis court-sized spacecraft has probed some of the planet's deepest, darkest secrets with a suite of high-tech instruments. Here are some of the most fascinating scientific discoveries made by Juno at Jupiter, and a taste of what's possibly to come since the probe has several years of exploration left before NASA crashes it into the planet. Juno's closest flyby of Jupiter lasts several hours and is called a perijove. During that time, the probe flies over Jupiter's North Pole and exits with views of the South Pole. Juno passes within thousands of miles of the planet's surface during a perijove, enabling the probe to make detailed and unprecedented measurements of gravity, magnetism, and plasma fields using a suite of high-tech instruments. It also beams back stunning images. So when the probe flew over Jupiter's poles for the first time and sent back data, it blew scientists away. Some observatories, like NASA's Hubble Space Telescope, had recorded auroras on Jupiter's poles, but nobody had ever seen the enigmatic regions in the detail Juno revealed. It looks like nothing we have seen or imagined before, Scott Bolton, a planetary scientist at the Southwest Research Institute in San Antonio and the Juno mission's leader, said in a NASA press release in September 2016. It's bluer in color up there than other parts of the planet, and there are a lot of storms. There is no sign of the latitudinal bands or zone and belts that we are used to. This image is hardly recognizable as Jupiter. 1. Jupiter's weather goes much deeper than you think. Juno's first ultra-close pass helped researchers peel back Jupiter's atmospheric layers like an onion and see hundreds of miles deep into the planet's hydrogen, helium, and other gases. The structure of the zones and belts still exist deep down, Bolton said during a news conference in 2016. So whatever's making those colors, whatever's making those stripes is still existing pretty far down into Jupiter. That came as a surprise to many of the scientists. Later studies reveal that the appearance of belts, bands, and storms may originate more than 1,900 miles below the planet's gassy surface. In addition, NASA released eye-catching images of symmetric clusters of storms. The images were created from multiple photos taken in infrared light. Next, scientists merged the pictures together, made them 3D to emphasize brightness and temperatures. Scientists are still trying to understand what exactly creates these stormy supercells that stretch thousands of miles wide. 2. Most of Jupiter's lightning is concentrated in the North Pole. During Juno's first 8 perijoves or flybys, the spacecraft detected 377 lightning discharges via their crackle of radio emissions. When researchers mapped the locations of the lightning, they found it concentrated at the planet's poles, not its equator. Researchers think this happens because when the sun warms Jupiter's atmosphere, the heat stabilizes the planet's mid-areas against upwelling storms. But at the poles, where it is much cooler, big cells of warmer inner gases can punch to the surface and create lightning. Weirdly, most of the lightning was recorded at Jupiter's North Pole, which is something researchers have yet to explain. 3. Gravity is lopsided. Juno has a special instrument that allows it to precisely map Jupiter's gravitational field. The first major results from that data shows that field is slightly lopsided, with a bit more pull from its northern hemisphere. Researchers think this is tied to Jupiter's deep-running weather systems, which can push huge masses of its atmospheric gases to certain parts of the planet. In addition to gravity, Jupiter's magnetic field is also lopsided, and it's the strongest in the solar system, driving all sorts of important behaviors, including polar auroras, plasma fields around the planet, and radiation that can threaten space missions. So, it's important to understand in detail. Luckily, magnetic instruments on Juno can continuously map the planet's magnetic field. Those readings have surprised researchers in multiple ways. They showed that Jupiter's magnetic field strength is about 2 times more powerful than researchers previously thought. The data also revealed that the entire magnetic field, like the planet's gravity field, is slightly lopsided. The reasons for that have yet to be explained. 4. Jupiter appears to have more water than anyone expected. Newly released data from NASA's Juno probe shows that water may make up 0.25% of the molecules in the atmosphere over Jupiter's equator. While that doesn't sound like much, the calculation is based on the prevalence of water's components, hydrogen and oxygen, 3 times more than at the Sun. The new measurements Juno obtained are much higher than a previous mission suggested. The surprise result has scientists delving deep again into the results from NASA's Galileo mission to Jupiter, which obtained drier results in 1995 when engineers deliberately threw the spacecraft into Jupiter's atmosphere. Therefore, reconciling the results from Galileo and Juno is key for scientists to better understand how our solar system came together, NASA said in a statement. Since Jupiter was probably the first planet to form, it would have sucked up most of the gas and dust that the Sun's formation left behind. How much water Jupiter soaked up then should help scientists identify the most plausible theories to explain its formation. And understanding Jupiter's birth would, in turn, help scientists understand how the planet's wind currents move and what its insides are made of. So scientists should be able to generalize findings at Jupiter to certain kinds of large exoplanets to learn how other solar systems formed. Galileo's results were a puzzle even back in the 1990s, as the spacecraft sent back data showing 10 times less water than scientists predicted. And more weirdly, the amount of water appeared to increase the deeper Galileo went into Jupiter's atmosphere, according to the NASA statement. 5. Something strange powers Jupiter's auroras. Auroras start with a planet's magnetic field. The field grabs charged solar particles blown into space, then race them toward the planet's poles. When the particles slam into atoms of gas in the atmosphere, they create a light show. But Juno researchers have discovered that Jupiter's pole auroras have 10 to 30 times more energy than expected. And they give off that energy mostly in ultraviolet light, which is invisible to human eyes. What's more, the auroras dim when the planet rotates into darkness. Researchers have yet to figure out how auroras work on Jupiter, though they suspect it has something to do with an energetic field of plasma around the planet. Coming to the conclusion, the mission around Jupiter holds a great importance for scientists, as they believe that trying to understand how Jupiter gathered early ingredients from the solar system can also tell us a great deal about how planets formed, including ours. We humans are made out of those same ingredients. We took those ingredients and made a robotic spacecraft to explore this other planet. So it's an effort that will reinforce our connection to the cosmos. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.